Video, we are going to start talking about linear inequalities. Now, these are very similar to equations. It's just now we have slightly different symbols that we're using here that mean different things. Okay, so just as a quick um, probably review, we basically have four different kinds of symbols we can see when we have a linear inequality. Okay, we have this symbol, which means strictly less than. Okay, we have this symbol, which means strictly greater than. And then we have this symbol, which is less than or equal to. And then we have this symbol, which is greater than. Okay. And so if we have, let me just move these. If we have something like x is strictly greater than 7, we can think of this as all x values greater than 7. And if we have x less than or equal to 3, this is all x values we can think of as up to and including 3. Okay, so this is kind of what these different symbols mean, and you can replace this with any of the symbols that we had just previously mentioned. But this is sort of how this works. Okay, but other than that, you basically solve these just like you would uh, um, any other type of equation. The only thing that you have to remember is that if you multiply by a negative number on both sides of the inequality, or divide by a negative number on both sides of the inequality, you have to flip the direction of the sign. Okay, so if you were to divide both sides of this first one by a -1, you'd have to flip this to negative x is strictly less than -7. Okay, that's really all we're saying here when we do that. So let's take a look at this first example. I think you'll find these are a lot like equations. We have -8 is greater than or equal to x over 3 minus 5. Okay, so our first step will be to move this 5 over to the other side so we can isolate x by itself. These will cancel, and then we'll end up with -3 is greater than or equal to x over 3. Okay, and now what we do is we multiply both sides by 3. This will cancel, and we'll end up with -9 is greater than x. So we are greater than or equal to x. So we're looking at all x values that are less than or equal to -9. Okay, and we'll do some of this later. But if you were to think of this on a number line, okay, let's say this is -8, -9. Oh, sorry, I'm going backwards here. -7, -9. -10, right? We would graph this by doing a little closed dot here, okay? And we want all values of x that are less than. So the go all the way back to elementary school here. The alligator's mouth is opening to the -9, so -9 is greater than or equal to x. So we're going to shade in everything to the left on the number line, okay? So looking for all x values that are less than or equal to -9. All right, let's take a look at this one. we have 6x plus 3 is less than or equal to negative 15. So we can start by taking 3 away from both sides. And we'll end up with 6x is less than or equal to negative 18. We divide both sides by 6, and we'll end up with x is less than or equal to negative 3. Okay? And again, we can graph it very similarly to how we did before. I don't believe Alex specifically asked you to do this for these, at least not yet, but I'm sure it will come up in the future. So negative 4, negative 3, negative 2, negative 1, 0, right? So we would draw a closed dot here at negative 3 and shade in everything to the left. Okay? That's roughly how you would graph it. Okay, now sometimes when it comes to inequalities, just like with equations, you can end up with situations where you have either no solution or all real numbers as solutions. So let's look at examples where uh, um, we see some of each. Okay, and just like with equations, if you're going to end up with all real numbers being solutions, you're going to eliminate all of the variables, and you're going to end up with an inequality that is obviously true. Okay, we're left with nothing but constant terms, but the inequality is true. If there's no solution, you'll end up with all constant terms where the inequality is false. So we're going to see a couple examples here. Let's take a look at this one. Here we have 2 times 6w plus 9 is greater than or equal to 12w plus 14. So the first thing we ought to do is go ahead and distribute this 2. So we'll have 12w plus 18 is greater than or equal to 12w plus 14. So let's take the 12w away here. So cancel, but so will these. And we're left with 18 is greater than or equal to 14. And if you're left with something like this, you have to ask yourself, is 18 greater than or equal to 14? Well, yes, it is greater than 14. So we know that since the inequality is true, that means that all real numbers satisfy this inequality. So you can plug anything in, and it will end up being true. Okay? Let's take a look at another example. Here we have 3 times 7 minus x plus 3x is strictly less than 21. So let's go ahead and start by distributing this 3. So we'll end up with 21 minus 3x. Then we have plus 3x, and that's going to be strictly less than 21. Okay, well, these 3x's are going to cancel, and now we're left with 21 is strictly less than 21. Now, the key word here is strictly less than, okay? So 21 is not less than or equal to 21. If you had that symbol, 21 is less than or equal to 21, that would be true. 21 is equal to 21. But we have 21 is strictly less than 21. That statement is not true. Statement is not true. Therefore, we have no solution.